Moving on. We got to disconnect the fuel line at the filter because now we're going to get set to take off the muffler and the fuel tank and the heat shields. Okay, and so move the electric start button out of the way. Here you can see here my fuel filter and the fuel line from the tank and the fuel line that goes to the carburetor and these constant tension spring clamps that hold the line onto the filter. So first thing we need to do is release the clamp from the line. Usually easiest to do with a pair of combination slip joint pliers. A set of needle nose pliers will also work, but I prefer the wider jaws of the combination slip joint pliers. So I'm going to grab this and I'm going to take and squeeze the two little tabs together, and then I'm going to pull and wiggle the hose clamp off of the filter barbs and down onto the line. Okay. This is why the needle nose come in handy, is now that I have that, the hose is going to be stuck on the end of the fuel filter hose barbs pretty good. So what I like to do is take my needle nose pliers, not squeezing the handles together, but kind of using the needle nose pliers as a bit of a pry bar to push on the end of the hose. I can use that to push the hose up and off the hose barbs a little bit so that it's easier to pull and wiggle the hose off of the hose barbs. Okay? I can leave the fuel filter connected to the fuel line that goes to the carburetor and just leave this side disconnected on the tank side. Next thing we're going to do is we'll go ahead and we'll take and remove our muffler. Our muffler is held on to the cylinder head with these two nuts on these studs here. This top cover, while you can see some screws there, this is a heat shield that we don't need to remove because it's attached to the muffler. So when we unbolt the muffler at the cylinder head, the heat shield will come with it. The nuts for the muffler are 13 millimeter, so I've got a 3/8 ratchet with a 13 millimeter deep wall socket, and I'm setting the counterclockwise position here. They're going to be a little bit tight, which is why I went with the 3/8 ratchet. It's going to have a longer handle, give me some better leverage and torque that I need, versus a 1/4 inch. 1/2 inch might be a little bit much, but 3/8 works. They should crack loose, and once they're loose, they should spin relatively freely for you. So I'll take these off and I'm going to set them off to the side, trying not to lose them. Once I have that off, your muffler pretty much just lifts off the stud. There should be a gray or a silver colored gasket, hopefully stuck to the cylinder head. Some might find that it's stuck to the muffler. Either way, it's fine where it is. We're going to go ahead and leave those on there and leave them intact because this is a training class and we're only going to run the engines for a little while after we finish rebuilding them. We're trying to save a few bucks by seeing how many times we can reuse the gaskets. In a normal rebuild situation on a customer machine, we would definitely put brand new gaskets on every gasket we disturb. But in this case, we're going to try to save them and reuse them. So leave it where it is. Your muffler can be set off to the side. We won't be needing that for a while. And the nuts, I find it's best to park them back onto the studs from where they came. And that way we'll know exactly what they're for and where they are when it comes time to reinstall the muffler. Okay? There's a heat shield over the top of the cooling fins. We're going to want to go ahead and remove those. And holding it on is one 8mm bolt head right here. And so I'm going to use my trusty tri-drive T-handle. That's got an 8, a 10, and a 12. And they're 1/4 inch drives, so they're interchangeable. You can move them around to where you need to. The long one here, not as much torque, but you can spin it and go pretty fast with it. Whereas the short runs here, the T part, gets you a longer handle for more torque. So usually I find that I can just stick the 8 on the end and the 10 and the 12 on the T part, and I don't have to move them around too much, but I can if I need to. So it's just a little 8mm short bolt, comes out. This is where the cardboard is going to come in handy, or parking our bolts back in the holes. And then the heat shield just lifts right off. I'm going to set this over with the muffler, because I'm not going to need that again until I'm nearly done reassembling it. Since this one doesn't get in the way of anything else, I'm going to go ahead and park it back into the hole from which it came, and I'm just going to give it a few turns in so that way I know exactly where it is when it comes time to reassemble the engine. Up next, it's time to take off the fuel tank. It's held on by 3 bolts. There's one in the back here, also an 8mm, so I'm going to loosen that one. Okay, and I'm going to leave that one in there, but loose. And then I'm going to rotate the engine so you guys can see the front side of the engine. Tilt it up a little bit here for you. We've got a bolt right here by my finger, and then underneath and behind where the fuel filter was, where I just stuck my T-handle, is another 8mm bolt that holds the tank on. This silver plate right here is also going to come out with the tank. Let me get those cracked loose. Pull these ones all the way out. I'm going to set them off to the side for the time being. Okay, the bolt came out, it's loose. You can either let it sit in there or you can try to push it out or dump it out. And then now I've got the tank still held on by that back bolt. I'm going to hold the tank with one hand and remove the bolt with the other. So there's my 3 bolts. I can kind of lift up on this a little bit. Here's that bracket that can come out and be set off to the side. In order to take the line out, I've got to take the clamp off the line so the hose can pull through the bracket here. So I'll take my pliers, squeeze these 2 clamps together. You might be able to do without the pliers if you got strong fingers. And we'll take the line out. This is a protective sleeve. I'm just going to wiggle this back into the hose. Dry rubber on dry rubber sometimes takes a little bit of putzing because there's a lot of friction there. Get that back into the hose, and then I'm going to take my fuel line clamp. I'm going to go ahead and put it back on the fuel line so that way this doesn't fall off and everything stays together. But now I can safely go ahead and set this off to the side. I'm done with it for a while. And now we can see the top of the engine. And we can answer the next round of questions in your disassembly packet, such as inspecting the cooling fins, which are these aluminum looking fins right here on the cylinder and cylinder head. And if this was an engine that was used on a machine, it's possible that these are dirty. If this is a lawnmower engine, they could be packed with grass clippings, etc. So we want to check and see if there's any debris in it. That would give us an idea if this engine's been running hot or has maybe overheated from plugged cooling fins. I don't see anything, so I'm going to go ahead and write none in my packet. And then we're going to, since we can see more of the engine, especially the governor linkage in the top of the carburetor and the governor spring, I want to look at this, maybe look to see if there's any obvious signs of something missing, broken, bent, otherwise damaged or leaking. Everything looks pretty okay here. This is what it should look like when you take the muffler and fuel tank off. So I'm going to put none here. I didn't find anything noteworthy. Next step, step 12. We got to take off the linkage for the carburetor. This is my carburetor or governor linkage, and this is my governor spring. Before I can take the carburetor off, I need to take this linkage off. But before I take this linkage off, I need to make note or take a picture of how it's installed. This is easy to forget, and some engines have much more complex linkage setups that if you don't take notes or if you don't have a picture reference, it takes a long time, and there's many variations or different ways to put it together to find one that would work, or the right way that would work. So it's always best when you're working with governors on engines to, put that smartphone to use and take a snapshot before you take it apart. So took a picture with my camera. In your packet, I left you a spot where you can draw it out a little bit. You can take some notes. If you're going to elect to take a picture with your smartphone, that's fantastic. That's probably the best way to do it. Make sure you keep your picture, back it up to the cloud or something, email it to yourself, and then B, write down in the notes part that you took a picture and you put it with your phone, so that when you go to put this back together and you're like, oh, I don't know how this goes, I'm going to say, well, what about your picture? And you're like, I don't remember taking a picture. And I'm going to say, well, what did you put down in your packet? Okay, so make sure you do that, and then get it checkpointed, because that's step 13 is checkpointing. To actually take this apart, on the carburetor side by the throttle here, I'm just going to lift up on the linkage, and it'll pop up and out of the throttle plate bracket on the carburetor. Same thing for the other side, and look, this side already came loose. But this one just rotates up through the hole, and then the little spring unhooks. Okay? We're going to take these two items and we're going to tape it to our cardboard. So I got my cardboard here. I'm going to put these on a cardboard, and then I'm going to put a piece of masking tape over it so that they stay put, they stay there, and they don't get bent. As far as my gas tank bolts, these aren't really going to be in the way of anything either. So I'm going to go ahead and park these back into the holes from where they came. I could, if I wanted to, also take a small Phillips screwdriver and carefully, without poking myself in the hand, poke some starter holes into my cardboard. Gas tank has 3 of them. Put my bolts in there, and then take my pen, circle them in, and then label them gas tank. So that way I know that there was 3 for the gas tank, and these are my 3. That way I get them put back in the right spot. You'll notice that a lot of our engine fasteners are 8mm for a socket size. However, they come in various lengths, and gas tank bolts don't really work very good at holding down crankcase covers or starter motors or magnetos. So you got to make sure you kind of keep them straight a little bit. So I got my linkage off, which is great. I also need to take off my governor spring. Easiest way to do that is to take a needle nose pair of pliers, come underneath the little loop where it goes into your governor arm, grab it and rotate it up and out. Okay? It usually pops out pretty easy. If it's not easy for some reason and doesn't seem to be working like you're seeing it work here in the video, then that's your first clue that you need to come find me, ask me a question, be like, hey, Mr. Burkowski, this isn't coming apart like how I saw in your demonstration. Can you come take a look at mine? And then this just unhooks. And I'm going to go tape this down next to the governor link and slack adjuster spring that went to the carburetor there. Okay? At this point, it's now time to remove the carburetor. Also, at this point, it's going to be easier for me filming this to set the engine up on its PTO side here. But obviously, it's not going to balance on the end of its PTO shaft. So what I have are a variety of engine stand boxes that have a hole in the middle for the PTO, so that can go in and lay flat without teeter-tottering or rocking around on Okay. So holding our carburetor cover and carburetor on are a set of two 10mm nuts. So I'm going to swap around my 8 and 10 on my T-handle. These shouldn't be that tight. Should be able to break them loose by hand. They should spin off pretty easy. Take my nuts, set them off to the side for a moment. I plan to park those back on the studs later. So I lift off the cover. It's going to open up, and the cover is still going to be attached to the engine by the wires that go to the Magneto from the kill switch, and by the hose that goes from the primer bulb to the top of the carburetor. So before I get overzealous and slide this up the studs, I want to disconnect the wires of the kill switch. The one on the inside here is easy to get to. The one on the back side is a little bit harder. So I'm going to take my needle nose pliers, I'm going to go in here and I'm going to grab the metal connector part, and I'll pull and wiggle. It should come off without having to resort to extraneous force. And then after that, lift up the gray hose, up and around the choke lever, and the carburetor and cover will lift off. Okay? And we can leave these as a sub-assembly for right now. We'll set this off to the side and we'll come back to it later. If your carburetor is leaking fuel as you're removing it, that means that the previous person that rebuilt and ran their engine didn't empty the float bowl by loosening that screw. 1 or 2 blue rags should be enough to wipe up or soak up whatever dripped out of them. Go ahead, wipe it up, put the flags in a flammable disposals can, and move on. So now that the carburetor's off, you'll see I have a gasket / heat shield. I'm going to want to take this off. I have a special place to put this that I will insert a clip on where this goes. Okay, so I've got my carburetor gasket / heat shield, and I need to go put it on the gasket board to keep it safe. And if I look around here, I'm in between a table here and a table there, and then I've got a column in the middle of the shop. And on the front, we have some engine part specifications and some torque specification charts that we'll look at later. But right now, I have a board labeled Toro 99cc. That's our engine. And you can see already on it are some gaskets and heat shields. And so what all I'm going to do is I'm going to take mine. I'm going to put it right over the studs there, and put it on there, and that's going to keep it safe, so that it doesn't get banged up or beat up in your locker, because like the muffler gasket, we're going to try to reuse this. So we'll set this off to the side for now. You also have this black phenolic spacer. We can leave that on the studs, and to help keep it on studs, I'm going to take the nuts and park them back on and hand thread them out a few turns. Okay. Now the carburetor's off. We're going to go ahead and remove the engine shroud now. The engine shroud is this black housing. The recoil is bolted to the shroud. These 3 bolts, you can leave them alone. They don't need to come out. What we want to take out are going to be these 2 bolts up here and these 2 bolts down here. Okay, those are going to be 8s, so I'll swap my 8 back to the long end of my T-handle, and I will crack these loose in a counterclockwise fashion, spin them out. So I got my 4 bolts. I'm going to set these off to the side and put them in my cardboard. Okay. Make sure that you put all your bolts either back in their holes or into the cardboard and label them before the cleanup part of the period and before you leave. because you may or may not remember the next time you come to work on your engine. And then that's how people get frustrated, because they're constantly having to ask or spend a bunch of time figuring out what bolts were because they didn't take the time up front to keep their process organized. So make sure you do that. It will help you in the long run. Once you've got those 4 bolts out, your whole shroud can lift up and off the engine, okay, with the recoil and the adjustment for the governor spring all intact. You don't need to take that off. That can all stay. And what's really cool is now this becomes like a handy dandy little parts tray that you can put other parts into and store them in the back of your locker. So usually I put the carburetor and some other random pieces like heat shields and Magneto that we'll take off here in a little bit. Put those into there and put it in the back locker because we won't be needing those again till reassembly time. Next thing, we need to take a measurement before we move on to our next part removal. If we take a look right here is our Magneto, or solid state ignition module, depending on which manufacturer and manual you're reading. This is what generates a spark for your spark plug. You can see my spark plug wire and my 2 stop switch wires run through this sheathing here and to the Magneto, and it's held down by 2 8mm bolts. On the flywheel here, this is the flywheel, there is a magnet. Okay? As the magnet spins past the Magneto, it generates a magnetic field inside the coil of the Magneto, and when it collapses, as the magnet moves beyond the Magneto, it induces a voltage that travels to the spark plug, jumps the gap of the spark plug, etc. We'll talk more about that when we get into the ignition systems. But the air gap, or the space between the magnet and the leg on the Magneto, is important. It needs to be big enough that as the flywheel thermally expands from running and getting hot, that it doesn't hit the Magneto. But it also needs to be as close as possible, the Magneto needs to be as close as possible to the magnet to be able to develop the most amount of spark as needed. So we want to see what this gap is. If I have an engine that doesn't have spark, and maybe somebody's worked on it before they brought it to me, this is one of my areas of concern. Well, hey, maybe they took this off because they needed it out of their way, but maybe they didn't reset the gap proper. Maybe a stick got in here and it hit this and it was able to move or bend it out of the way. So to measure this gap, because it's a pretty small gap, I have these brass feeler gauges that can be found in cabinet 3. There's little strips of metal. Each one is a different thickness. The thinnest one here is 6/1000 of an inch, and the thickest one is 16/1000 of an inch, 0.016 inches. And so what I want to do is find the one that fits in the gap with a little bit of resistance, okay? And it just so happens here, I got it on the first try, and this is 0.08, or 0.008. I'll see if I can hold this up. They're really hard to see because they're older. But see, there's a 0.008 on the top, and then there's a 0.203 mm for the bottom. So they're labeled in both inches and millimeters. Just pick one and write it down. Okay? If it goes in really easy, your blade is too thin. If it doesn't go in at all, the blade you have is too thick. You got to try a thinner one. Okay? If your gap is excessively huge, you may have to stack a couple together and add the 2 measurements together. The whole reason that they're brass is because we want to measure where the magnet is, because the magnet's going to be the farthest part that sticks out from the flywheel. And a regular steel feeler gauge set like these are magnetic, and that affects the way it feels. Because they're called a feeler gauge, it's because what we're feeling for is a little bit of resistance from a gap that's been properly filled with the leaf gauge, for lack of a better way to describe it. Okay? Because if it's too thin of a leaf, it'll just slide through usually no problem, and it'll be really loose. Okay? So there's got to be a little bit of tension or resistance to it moving in and out of the gap. Mine is 8 thousandths. I'm going to go ahead and record that in my packet where it says air gap found. I'm going to write down 0.008 inches. Okay. Anytime I write down a measurement, I want to make sure I label the units. Since I'm using inches, I left the inch mark, which is a double quote. And then get your checkpoint checked. Once you take the Magneto off, I won't be able to tell whether you measured not or right, and then it makes it hard for me to give you full points.